Hello, Geography 231 students. Welcome to a week 6 tutorial. This week we are going to be doing density mapping. So again, my caveat whenever I start one of these tutorials is make sure you've already watched and read the lecture notes. Make sure that you have a fairly clear understanding of what the topic is before you get into the tutorial. And also take a look at the actual lab itself. So on that note, we are officially in making spatial decisions using Arcgis Pro, and we'll be using it intermittently throughout the rest of the semester. This particular lab comes from Chapter 3. Chapter 3 is it's called Law Enforcement Decisions. There are actually two sections. We're going to do Section 1 this week, and we'll do Section 2 next week. They rely on the same tasks and the same geoprocessing tools. So whenever you'll become familiar with this book, and if you took Geography 231 with me last semester, you'll already know that Section 1 of one of these chapters has every little detail spelled out for you, and then Part 2 of these chapters basically expects you to know how to get from point A to point B when it asks you to do a task. So essentially next week when you're on Section 2 by yourself, you can always return back to Section 1 to figure out how did I symbolize the data by heat map symbology, or how did I come up with a tessellation symbology or something like that. So just know that the skills that are introduced in Section 1 will be necessary for you to be able to do Section 2 on your own next week. All right, so okay. We are going to be, obviously, you're going to need the textbook, you're going to need your browser. The first thing you're going to do is you're going to need the actual spatial data itself. Okay, so what this book does, every chapter, it asks you to go into arcgis.com and download a map package, or it's actually a project package, and the project package contains all the data that you need. It's actually a really handy way to do it. It used to be that you had to have a textbook with an actual physical CD and you uploaded the data onto your hard drive, but now my computer doesn't even have a CD drive, so it's nice to have everything hosted on the cloud. So navigate to arcgis.com on your browser. Go ahead and hit enter, and then sign in with your Cypress College username. All right, it should be GEOG 232, whatever your number is. And if for whatever reason you don't remember what that is, you should already be logged in on Arcgis Pro. So just go onto Arcgis Pro and see what your username is. I can't help you with your password unless you need to reset it. If you need to reset your password, I can do that for you, but hopefully you remember what it is. So your screen's going to look different than mine. Yours might look a little bit more like this. You're going to have content and everything, but it's okay. At this point, all you need to do is just click this little search box right here, and then do a search for Esri Press, one word, underscore MSD, that's making spatial decisions, underscore ArcGIS. Do a search, and you're going to be like, oh no, nothing came up, right? No items found. So what you're going to do is you're going to change two settings. You're going to switch from content to groups. Then you're going to uncheck only search in Cypress College. So what that does is it looks for all groups owned by Esri Press, MSD, ArcGIS, and it looks outside of Cypress College. By default, all search results remain within your organization, and that's basically to get you the most specific, accurate information or data as possible. So like last week when I had you download the Orange County boundaries and the US states layers, those are layers that I uploaded myself to our organizational account. Then you're able to download those. In this case here, we're actually looking for data from another provider outside of our organization. And Karen and Culver, those are the last names of the two individuals who wrote your textbook. This is their data set. Let's go ahead and click on the username there. And then we want DC data. So if you scroll down, you may see it here. I don't, so click on View All Group Content, and then there it is, DC data. So don't click the name. What I want you to do is click on the three dots here, the options, and do download. So download the data. It's going to go into your downloads folder most likely. And then you can leave it in your downloads folder for now, but ultimately what we're going to be doing is unzipping it, but we're going to use a tool in ArcGIS Pro to open the project package. So rather than using like WinZip or something like that, you'll notice that the file extension is .ppkx. That's a project package is the extension. And so we're going to use Arcgis Pro to open that up. All right, so let's go ahead and open up Arcgis Pro. And new. And then the book has you do it a little bit differently, but I'm going to have you do it this way instead. If you follow the book, you're fine. You'll be able to get there too. But the book is a little out of date. So obviously we're on version 2.5 or whatever it is now. And so the book came out before 2.0, I believe. So go ahead and click on Map. And then for the project name, let's call it DC Results. And then just save it to whatever working folder that you have been saving your classwork in. That will obviously vary from student to student. And you notice if you're following the textbook, the next step is saying add a new map. You don't need to do that because of the way we just did it. It automatically creates a map, a default map. Okay, so we're going to jump straight to step 5 here, which is the Analysis tab, Tools, and you're going to do a search for Extract Package. And this is essentially the package extractor that's used to open up zipped or map packages or project packages here. So go ahead and open that up. You need to now browse to the data in your downloads folder most likely. Go and hit OK. And then you have to choose an output location. So in this case here, you're actually choosing a folder, not a geodatabase. It's a whole entire folder for all of the data to go into. So go ahead and hit the browse button. In my case here, I've got a class folder for our semester, assignments, and then a week 6 mapping density folder. You might want to create something like that. So go ahead and hit OK. Then leave cache package checked and hit run. And all the data will unzip, unpackage, if you will, into that folder. All right, so once it's done, it's done. You then can open up your catalog pane, and we're going to create a folder connection to that project package. So right-click on folders in the catalog pane, add folder connection, browse to the location where you unpackaged the data, and just select the folder. You don't need to actually choose the data itself, just the folder that holds the data. Hit OK. And so my folder connection is to week 6 mapping density, and within it I've got DC results, which was created when we created this project. And then these 3, actually 2, this one is from it's mine. You don't need to worry about that because I had to practice this before I did the recording. But you should have a folder there called Common Data and P13. Those are the 2 data folders that were just unpackaged. Okay. So go ahead and click on P13 to maximize that folder, and then maximize dccrime1.gdb. The name is a little bit different than what you see in the book, and it has that 1 appended to it. I don't think that's what it was in the book. Go ahead and open that up, and then you're going to have a feature data set called layers, and within layers, 6 featured classes, and we actually want them all added to the map. So you can just click and drag the layers feature data set onto your map. And not only will that put all layers on the map, it will also project your map into whatever the native projection is from the first feature class that was added to the map, which in this case it's a UTM zone 18 north, I believe. UTM is a projected coordinate system, covers the whole United States, I think maybe the whole world. Universal Transverse Mercator zone 18 north for Washington, D.C. It's not too different from a state plane, different method, different central meridian and other details, but at any rate, so we add that in there, and then let's turn on and off the layers just to kind of get a feel for what they do. So we got Crime 2015 that has, obviously, as you can imagine, a bunch of crimes, metro stations from the train line, police stations, the metro lines themselves, DC, which is the boundary of Washington, DC, and police districts. So let's take DC, drag that to the bottom, and then we're just going to quickly symbolize the DC layer. Let's go ahead and click on the color chip for DC, and let's click on this solid fill. We'll make the fill color about 50% gray, and then we'll make the stroke black, and then let's quickly click on appearance and make it about 70%. Oops, sorry, finish those symbology steps first. I jumped ahead. Outline, black, cell stroke, 50% gray, apply. Do as I say, not as I do, right? Then click on appearance and set the transparency to 70%, just about. Okay. So if you turn off police districts, you'll be able to see. It just gives you a rough idea of what the boundaries are for DC. And we're not going to use it too much. We just really need it for spatial reference. Okay. So you can turn on police districts and just leave all the layers on for now. And go ahead and save your project at this point. And then right click on the contents pane, the name of the map there. Just click on map, right click, properties, and bring up coordinate system. And we'll just verify that this is indeed, yes, NAD 83, UTM zone 18 north. And we're going to need that information because we're now going to do an environment setting to change the output coordinate system and set a mask for processing. So it's always good when you know you're going to be doing geoprocessing, it's always good to go to the analysis tab and click on environments and make sure that your environments are accurate and set. Otherwise, you run the risk of having data that is in some other coordinate system, or if you're doing processing, if you only need a raster for a limited area, you end up creating a raster for a much larger area, and that uses up bandwidth and storage and everything. So output coordinate system, hit the drop down and just choose current map. Because our current map has the UTM zone 18, that'll just import it. And then for processing extent, go ahead and hit that drop down and choose DC. So it'll limit all processing to Washington, DC, the boundaries. And then likewise for raster analysis for mask, hit the drop down and choose DC for that as well. So when we end up creating a raster, it will be limited to the area of Washington, DC there. All right. Go ahead and hit OK. Now it's good. Save your map now that you've done your environment settings. And then this is something that I want you to do because you're going to be returning to these steps when you do section 2 next week. On page 105, it says create a process summary. So a process summary lists the steps that you used to do your analysis. The summary is important because it will allow you and others to reproduce your work. We suggest using a simple text document, just like Notepad, to document your steps. Keep adding the summary as you do your work to avoid forgetting any steps. The next list shows an example of the first few entries in the process summary. So go ahead and do that. Just open up Notepad or Microsoft Word, whatever you have access to, and then put in those first 4 steps. Extract the project package, produce, here, I'm going to actually do it here. So 1, extract the project package. I'm going to put in parentheses analysis tools extract package. Step 2, produce a map of Washington, DC, which we do that with the data from the project package. Step 3, establish service areas for police stations. And step 4, calculate crime within service areas. So those are the first 4 steps. Go ahead and save that, and then just keep it, and then you will refer back to that when you do section 2 on your own next week. Okay. So delivery 1, a map showing crime by district and crime within a 3-mile service area of police stations. Symbolize and classify the data. So this is going to be your first deliverable, is a map showing crime by district and crime within a 3-mile service area of police stations. So we're going to create that now. So turn on police districts. Oops. Okay, go ahead and turn on police districts. The layer, it's already on for me. And let's just turn off crime 2015 for a moment because there's just so many points there. And then we're going to make sure it's selected and click on Appearance. It's Police District's Appearance. Symbology, going to do unique values for the display style. And the value on which you will symbolize it is the name field. Okay, so each of these has a different name, and that will help determine the unique value. And then hit More and uncheck Show All Values, and that's just so that'll help you in the legend stage. Okay, go ahead and save your map at this point. The next thing we'll do is label. So make sure police districts are selected. And I actually skipped over a quick step. You might have caught this if you're going through the book. Change police_districts to just capital police space capital districts, police districts, just so it's proper English instead of kind of shorthand layer naming style. Okay, so make sure that it's still selected. Click on labeling, and we're going to go ahead and label this feature. And you can also just right-click and label that way as well, because we're okay with the default labeling style. All right. Now, in the contents pane, now I want you to select police stations, and we're going to change the name of that to capital police, capital stations, getting rid of that underscore and capitalizing the words. Then double-click the point symbol here, and that will bring up the Symbology selector for that point. And change the Symbology pane default style from project styles to all styles. So in gallery, first check gallery. Make sure you've got properties and you've got gallery. Hit the drop down here and change it to all styles. Mine was actually project the first time I did this, so yours is probably going to be on project. You want to change that to all styles. Then do a search in here for police. And we specifically want primitives, then the largest one. So you've got multiple versions. We want the black and white one down here without the circle around it. It's called primitives, police station. Go ahead and select it. Where is it? It's not showing up on my screen. I'm not sure why. Then close the Symbology pane. There we go. I don't know why that wasn't showing before. It's a little concerning. All right, once you've got your police station symbolized, save your project. And now we're going to examine metadata and fields in the attribute table. So turn on crime 2015. That's the layer with all the crimes in 2015. There's something like 36,000 of them. Then right-click and open up the attribute table. And then just take a look at the fields. So after object ID, you've got a field called CCN. That's criminal complaint number. So that's basically just the record number of every one of these crimes. And you've got different types: theft, burglary, auto theft, assault, motor vehicle theft, and so on and so forth. And so all the different crime data is in here. And then also notice that these are geocoded to block. And they do that to sanitize the data so that it doesn't give away anyone's specific location, or maybe block group actually, which is even less specific. So they sanitize the data by geocoding all the crimes to block group. And what that means is that if you've got 10 crimes in a single block group, they likely didn't happen in the exact same spot. They probably happened, within 500 feet of each other. But what ends up happening is that all 10 of those crimes get geocoded as a centroid, which is the center point of the block group, which is a polygon. So 10 crimes get geocoded to one single centroid location, which means that you might see one point on the map, but really 10 crimes occurred there. Okay, so just be aware of that. The next step, you can close the attribute table if you want. Next thing we're going to do is right-click Crime 2015, and then go down to Properties, and we're going to update the metadata real quick. Okay, so mine says Show Metadata from Data Source Read Only. Hit the drop-down and do Layer has its own metadata, and now it's editable. So for title, let's call it, let's see here. I think we're going to call it Crime 2015, which it already is. Okay. Tags, we don't need any. Summary, DC, index, crime incident location, Incident locations for 2015. And then this is a lot of text, so I'm not going to type it all in right now for this tutorial, but go ahead and enter that text as is. I'll say DC, index, etc. And then credits, http://open data.dc.gov, limitations, educational use only, and then hit OK. All right. Okay, so we've got our metadata put in there. And metadata is important because it helps you track. It's what we call metadata is data about the data. So anytime you make changes to a layer or attributes, its geometry or its attributes, you want to update the metadata to record or document the changes that you made. Okay, it's important because data are often meant for sharing. And so if you make changes to a data set, you want to make sure that whoever receives that data knows what you did, why you did it, when you did it, all that. Okay. So question 3 rather here is write a synopsis of the crime data. You don't need to do that. Actually, just pay attention to this assignment on Canvas, and I will include what I am actually looking for from you in terms of deliverables. So you'll see these questions in deliverable notes throughout the chapter. You only need to pay attention to those that I'm looking for. In this case, you can just skip over this, all right? All right, so next up, we want statistics of crime by police district. So you will now compile some statistics of crimes by offense for both the police districts and within a 3-mile drive time from the police stations. You'll use the Spatial Join tool, which joins attributes from one feature to another based on their spatial relationship. The target feature and the join attributes from the join features are written to an output feature class. In this instance, police districts is the target feature and crime 2015 is the join feature. So to do a join, there are actually multiple ways, but we're going to do the way the book says. You are going to click on the Analysis tab, and then right here, it's one of the common tools you use. So go ahead and click on Spatial Join. The most common tools are listed here. At least in theory, these are the most common. So Spatial Join, again, target feature, police districts, join feature, crime 2015, output feature, we're going to call it PD crime. So remember, I've introduced this before. The great thing about Arcgis Pro is you don't have to browse to the geodatabase location. You can just put your cursor in here and then go back to the last backslash before the current default name and type in the new name there. It's going to be PD_crime. And then make sure the join operation is join 1-to-1 and go ahead and run it. Okay, so look in your attributes, your contents pane, and there is PD crime. Okay, so the spatial join tells you the number of crimes per police district. Calculating the percentage of crimes per district would be much more meaningful than just knowing how many are there. So we're going to do that in a bit. The first thing we're going to do is change the name, which is really just changing the alias of this feature layer to crimes per police district. And then right-click crimes per police district and open the attribute table. And then we are going to add a field. Just go and click on Add. And this brings up the fields editor, which was introduced to you last week. And the new field name is going to be %. The type will be float, which is a floating decimal place. And the number format will be percentage with 2 decimal places. Okay. All right, once you've got the new field details input, you need to save. This is always key. So make sure that you're still on the Fields tab, which is a contextual tab. Save it. And then once it's grayed out, then you know that your field has been saved, and also this little green box goes away, becomes a gray box. And then before you close out of the fields editor, you're actually going to take the new field that you created, the % field, and you're going to drag it all the way up to the top, right below join count. There we go. Right below join count. So you'll see the first couple of fields here, object ID 1 and shape, are grayed out because they're automatically generated. then you have join count, and now we have our new percent field, and it turns green again because your attribute table's changed. So once again, you have to hit save. All right, now you can close your field editor, and notice that you've now got a percent field right there. Okay, so now that we have created our percent field and moved it to the beginning of the attribute table, it's now time to actually calculate the data inside, actually calculate the percentages. So go ahead and right click on percent, calculate field, and then per the book, we're going to build a expression, and we're going to double click the join count field once it's available. You're going to double click join count, and what that does is that just basically says, okay, so join count is the first value that we're going to be including in our expression. Next up, go ahead and click the / for divided by, then enter the total number of crimes, so 36,496 times, then we're going to multiply it by 100, and that's to make it into a percent. So right now it's obviously going to be a percentage, a decimal, not an integer. If you multiply it by 100, then it makes them all positive values greater than 1, essentially, or greater than 0. Then go ahead and hit OK and let it run. And because we made the numeric field a percentage, it automatically adds the little percent sign there into the attribute table. Okay. All right. Go ahead and close the geoprocessing pane if you still have it open. Mine's closed. And then close the crimes per police district table. You can also close the crime 2015 table if you've got that open as well. Now in the contents pane, we're going to click crimes per police district, and then we're going to go up to appearance to open up a Symbology. And then notice here there's actually, you may not notice, wait, no, never mind, no, this is good. Go ahead and follow the book on this one. There's an error in the book in a couple of pages. I jumped ahead myself, so just go ahead and follow the instructions. So change it from single symbol to unique values. And then we're going to symbolize on the percent field. Where is percent? Hello. Huh. Did I have the wrong one? Oh, there. I didn't see it. Okay. All right. So we've symbolized on percent because these are all unique values. Okay. And now it's time to label our data. So let's see. So actually what we're doing here is updating the label field here in the legend. So if you were to add a legend at some point, you would draw the legend values from this classification window here. So what you want is to just have one decimal place after every number. So 10.1%, 12.2, 14.0, 14.3, 15.6, 16.6, and 17.1. So you can go ahead and do that now. So I went ahead and did mine. So if you need to pause the video to do yours, go ahead and do that. Just go ahead and pause now because I'm about to move on. So next up, we're going to right-click Crimes per Police District, and we're going to label. Let's go ahead and click on Label. And so notice it automatically labels off of a specific field, but not the field that we are looking for. So right now it's hard to tell with the crime 2015 on it, but we have second district listed twice. All right, so what we're actually going to do is have the percentage value appear in the label. But the book has you do it a little bit, well, the book has you do it the right way, but you end up with a ton of decimal places. And so I'm going to show you how to run an expression in the labeling expression builder to chop off all those decimal places. So go ahead and click on the labeling tab. Make sure that Crimes per Police District is highlighted in the contents pane, labeling tab. And then what we're going to do is change the field to, actually leave that. Go ahead and click on, oh yeah, no, let's do this, okay. Change it to percent, and then go ahead and click on this button right here, which is expression. Okay, so we've got right now it's displaying the percent field, and if you are in this language editor and it's based in Arcade by default, we're going to leave it as that. We're actually going to build an expression around the percent field. So right now, if you have percent, it's kind of hard to see. I'll turn off the Crimes 2015 layer again. You can see 15.5496, blah, 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 14.023454. So we obviously don't need that. It's just too many. Also, we don't have a percentage symbol right now. So we're going to do something about that. So over here in this expression window, once again, you click on the expression button. It brings up this label class editor. What we're going to do is type in round. So capital R-O-U-N-D, open parenthesis. Going to put a comma after the percent and space 1, then close parenthesis. And then to make sure you did it right, go ahead and hit this little check sign to verify. It should say valid expression. And then hit, let's see here. Okay. There we go. Okay. So the one thing we are missing is a plus. Then let's see if this does the trick. That's what we want. Okay, so we go round, $ feature dot percent, comma, space 1, close parenthesis, plus, then it's open quote, percent sign, close quote. So what that does is that limits the number of decimal places to 1. We round to 1 decimal place. Then we add in whatever is inside of these quotes will show up after the numerical value. So you could just as easily have percent space of crimes here. Just see what happens. Don't do this, just watch. So you end up with 15.5% of crimes here, 14% of crimes here, et cetera, right? So whatever's inside those quotes will render as a label. Okay, so we just want to have it like that. Okay. Now the last thing we're going to do on this front is modify the police district crime layer symbology. So police district crime layer symbology. Make sure this is the right one. Yeah, the book is a little ambiguous, but it's referring to the crimes per police district. So all we want to do is change the symbology now so that it's hollow. So you can see the police districts underneath in color. We don't need the police districts colored twice. So make sure it's selected. Click on Appearance, Symbology, and then go ahead and change this back to, actually, let's see. It's the best way to do this. Make sure I don't mess it up. Should be fine. There you go. Okay. So click on the color chip and make it a black outline. There we go. That's what we're going for. Okay. So what we've done is we've made this crimes per police district a hollow fill with a black outline. I'm actually going to make it a little bit thinner. We do like 0.5. And we maintained the police districts underneath in the unique values colors. We have added labels to the crimes per district layer. And we've obviously symbolized the police stations as well. Next thing we're going to do is calculate the number of crimes of different types based on the drive time from the nearest police station. So the way we're going to do this is we're going to use the Network Analyst extension. So what Network Analyst does is essentially it has to use some sort of reference data. Generally, it's going to be a road layer. And so Arcgis Pro actually just pulls this road data from Esri's cloud service. Generally speaking, this uses credits, calculation credits, which if you were like a private person who had an ArcGIS Online account, you would have a finite number of credits that you essentially pay for. But because we have a site license at Cypress College, you don't go crazy, but you can obviously do this sort of thing in small amounts. So we're going to do this together as a class and use our Network Analyst extension. So first thing we're going to do is in the contents pane, turn off police districts. Turn that layer off. Okay. And also crimes per police district. So those two we're going to turn off. Then we're going to turn on the police stations layer, which is already on. It's already been symbolized. Then on the Analysis tab, Analysis, go ahead and click on Network Analysis. Okay, and then we want to choose Service Area. So this is the Analysis tab, Network Analysis, Service Area. And what this does is it actually builds out a temporary layer. Okay, I was going to call it a feature class, but it's really actually not a feature class. It's a temporary layer that essentially just appears for your needs, essentially. So what we're going to use it for is the service area, but you could also use it to develop the actual driving routes, which would be a polyline file, facility locations, which are going to be our police stations. We already have those. And it creates a temporary layer that exists that you can see in your map. But what we're going to do is take that temporary layer and then export it to a new feature class so it becomes permanent. So we'll get to that in a moment. All right, so notice the service area layer has been added to the contents pane. You can see that on your left-hand side. Facilities, polygons, lines, point barriers, line barriers, polygon barriers. So the layers together with the sublayers will contain the results of the service area solver that you will use to generate drive times from police stations. So on the Network Analyst contextual tab, click on the Service Area tab. Okay. Then before you can compute a service area for each police station, you must load the stations as the input locations for the service area solver to use. So on the top left, click on Import Facilities. And the import facilities will be the police stations. So for input locations, hit that drop down and choose police stations. All right, then go ahead and hit run. You can ignore the other settings there for now. Okay, so now you can see our police stations are still there. They're just covered up by the facilities. So essentially just took the police stations as an input layer, then took them and added them into this service area builder. Okay, a solver is the term it uses. Then on the service tab in the travel settings group right here, we're going to enter 3 for cutoffs. Okay, so cutoffs 3. Next you'll see drive times. Make sure drive times are set to minutes, which they are. Okay. And then in the output geometry group, choose split. That would be output geometry, polygons, overlap, and change that to split. Okay. So make sure that our polygons are split, and look at the other options there. We have overlap, and we also have dissolve. What split does is basically it says that this police station will only service this area. It will not overlap with or dissolve into an adjacent or nearby police station service area. So split means every service area is mutually exclusive. Okay, cutoffs are at 3. Drive times are in minutes. Go ahead and hit run. All right, so we have our service areas here. And you can kind of tell in this down here, oops, that would be DC. Ultimately, I won't identify it, but you can see that one service area does not bleed over into another. They actually have where their interface area is. There's a clear dividing boundary between these 3, these 2, these 2. There's no overlap and there's no dissolve. Okay. All right. So we ran it. Next thing we're going to do is make this temporary service area boundary or layer permanent. So you're going to right click on polygons, data, export features, and you're just going to save it into your standard geodatabase for the name. Let's call it 3 miles. Go ahead and hit OK. All right. So you can't see it right now. It's hidden by the service area layer. So we're actually going to, you can even turn it off or just remove it as the book says. So I'm going to right click on service areas and remove. And now we can see our permanently created 3 mile service area feature class. And then let's go ahead and change the alias to 3 mile drive time. 3 mile drive time. All right. Okay. Got 3 mile drive time. Next thing we're going to do is perform a spatial analysis. We're ready to find out how many crimes took place within each police station service area within 3 minutes of drive time. Okay, so click on 3 mile drive time, make sure it's selected. Then on the Analysis tab, we're going to go to Spatial Join, just like before. Target features will be 3 mile drive time. Join features will be crime 2015. Output feature class, after that last backslash, go ahead and call it just PS crime, PS underscore crime. Make sure the join operation is 1-to-1, and then go ahead and give it a run. Okay, so now we have a new, looks exactly like the previous one, even got the same symbology. We have a new feature class called PS Crime, and it took all of these Crime 2015 points here and all those that happen to be intersected with, or essentially overlaid with the 3 mile drive times. Those crime counts have now been aggregated into this PS Crime layer. Okay. All right, so you can close the geoprocessing window, and then we're going to rename PS Crime to Police Station Crime. Police Station Crime. And then we're going to change the symbology. And here's where the symbology actually, the book says to just change the police station crime layer to display by unique values. But we don't want that. We actually need some sort of quantitative value to determine the color gradient if we're going to match what's in the book here. So on page 115, notice that they sort of range from like a light peach up to a darker red. Well, that's obviously telling you that there's some sort of quantitative value here. So there's a slight typo in the book. So anyway, to take care of that, we're just going to make sure the police station crime layer is selected in the contents pane. Click on Appearance, Symbology. Then rather than choosing unique values, just go ahead and do graduated colors. And then field, let's make that field join count. Join count, looks like it already did that automatically. And then let's change the color scheme to red 5 class. So you can either try to guess based off of the image or just check show names. Now they're in alphabetical order. We want to find a red 5 class. Red 5 classes. There it is. Okay. So now your map should more or less match what you see on the page 115. The colors may not be identical, but you can still see in terms of the gradient scale, they more or less match up. Okay. So now it's a good time to save your project. Okay. And then this question 4, I'm actually going to have you answer this question. So we'll, on the actual Canvas assignment, you'll see there'll be a request that you answer this question, but just take note of it now. So write a report about the distribution of crime by police district and by the 3-minute drive time around the police stations. Describe both the spatial distribution and the spatial statistics in the report. Okay, so now might be a good time just to like take a couple of notes about what is the situation in terms of the distribution of the crimes and in terms of the relationship to the 3-minute drive time and within the different police districts. Basically, you want to find out like what districts happen to have the most crime in terms of density, and also what districts tend to have the most crime. That's really what I'm looking for. Okay. All right, so that's actually going to conclude the tutorial, but you on your own need to also work your way through deliverable 2. That's density maps for auto theft, burglary, and homicide. Those are going to be a raster density surface. You're then going to take that density surface and you're going to create isolines or contour lines from that. Next up, you're going to create a map showing the directional distribution of auto theft, burglary, and homicide, again using the Network Analyst tool. And then finally, you are going to create the tessellated grid, or the hexagon tessellations, showing distribution of, or density and distribution of crimes in DC with a tessellated grid. So those you'll have to do on your own. Otherwise, this tutorial would be like probably an hour and a half long or so. So we'll wrap this up here on my end. If you have any questions, reach out via email or Canvas Messenger or post on the message board. Yeah, so that concludes the tutorial, and best of luck. Bye-bye.